Assalamualaikum warahmatullahi wabarakatuh. My name is Nadia Shafika and today I'm going to present about our data mining tools, which is Tableau Prep Builder. So our group members consist of Alia Damia, me, myself and Alia Zarina. So for today, the content that we're going to discuss consists of the introduction of the Tableau Prep Builder, the data pre-processing, which is the data cleaning, data transformation, data discretization, and data visualization. So for the data mining task, it consists of classification, clustering, and forecasting. And lastly, we're going to conclude with the conclusion. So the Tableau Prep Builder is actually a data mining tools, which is a visual analytics platform that is revolutionizing the way we use data to solve problems. It's designed to make preparing your data easy and intuitive. For the Tableau Prep Builder, it helps with cleaning, shaping, organization the data before it can analyze. And it can gather a considerable amount of data from varied sources and transform them to a visual data. The role of data mining tools is to prepare the data and deliver a standard set of data rows that can select from, or you can create your own using the unique field value in your data set. The Tableau Prep Builder also provides a drag and drop interface that makes it easy to apply this operation and visually see the result in real time, where it can also support the creation of data flow, which are series of steps applied to the data to prepare it for analysis or mining data.
Hi and Assalamualaikum. My name is Arada binti Huzaimi and today I would like to present a part of data processing from the report, and mine is data cleaning. So data cleaning is the process of fixing or deleting incorrect image or incomplete data from a data set. Okay, let's begin. So once you open the Tableau application, you can see on the left side of the user interface is a triple dot. So by clicking the triple dot, it will come out a list of drop-down menu. So to use the data cleaning function, you will see the clean button, and once you lay down your pointer to the clean, it will come out another drop-down, which is a list of appropriate actions to clean up the data. So you may choose any of the actions to clean your data sets. So that's all from me. Thank you.
So I'm going to explain about the data transformation, which is a process of converting the data from one format or structure to another. It's also a process of mapping and transforming data from raw data to another for purpose of analysis. So for the first one, we can split transformation. For the split transformation, first thing first, we need to connect a new data source to the data mining tools, where the column and the row will containing a specific data. After we connect the data source to the data mining tools, we can click to the beside the column there is a drop down menu. After we click the drop down menu, the split option will appear, and then we can split the data by clicking the split option, and then it will split all the column that we are selecting that we want to split depending on the column we select. So for the second option, we can also custom the split transformation data, which is by specify the split of the first column to get a new column that can identify states in the data. The function of the custom split transformation, it can enable you to specify the delimiter character and the number of first and last column depending on what column you desire and you want to split it. So for the example, here I want to split the first column, so I choose the first column on the custom split window, and then I click OK. After that, it will custom the order ID column by split the first column of order ID. So here is the result of the customized column. For the last one, which is the pivot transformation option, it enables user to combine multiple columns into one, while the name of the value of the pivot field column that we select will combine the multiple column into two. So for this example, I select the desired column I want to pivot it, to combine it, which is the field name and the category and the subcategory column. In order for me to pivot transform the data, I need to control click on one of the column I want. So for example, the category column, and then I select also the subcategory column simultaneously, and then the pivot option will appear, and then I click the pivot option and it will combine the column that I already selected, as shown in the figure.
My name is Alia Zarina, so I will present about data discretization. Alright, so data discretization is a process of converting continuous data attribute values into a finite set of intervals and associating a specific data value with each interval. So the first step, you may convert the data or other numeric dimension to discrete or continuous formats. So there are two formats you can choose. So you can right click on a data field in the data pane and choose convert to discrete or continuous, and it will change the default behavior when you drag the data field into a view. As for the second step, when you change the format of the data or other numeric dimension, the data field will be colored in green when it is continuous, while it will be in blue if it is in discrete format. As you can see in the Canva, as I showed in the picture, the data field is in the blue, which shows it is in discrete format. And actually, for continuous dates, it will have an axis corresponding to a measure, while for the discrete dates, it will serve as identifiers. Okay, as for data visualization, it is actually to help people understand the information more quickly and relatable. As for example, people will more understand how the data set works and how it will be collected and how it will help for people to understand the problem and solve the data set. So the first step that you need to do is to connect the Tableau to the data file. For example, as shown in the picture is from the Excel file. By selecting the Excel worksheet that you would like to open, and by using the file selection box as you can see in the picture, and then click the button open to proceed with the data set. As for the second step, you might need to drag the orders sheet from the left navigation menu onto the drag sheets here box to display the data set. After we load the data file into the Tableau, we may do some data cleaning, pre-processing, and also other future extraction that you might need to do. And the third step, you might need to drag the dimension and measure it into the row and column input file, as I already mentioned at the third step here, and it will automatically recommend the best fitting graph based on the data. And you may see the best fitting graph as I put the picture on the right side of this slide. Okay, we proceed with the fourth step. So the fourth step is actually shows the step on how you want to visualize your data set. As shown in the picture, you might see the best fitting graph. Okay, so actually there is other ways for you to enhancing your data set, your graph, and also your analysis. So the first one, you might use the marks card, where the tooltips is actually offered to display information when you hover the cursor over the graph. For instance, there is actually a color button that is used to assign different colors towards different categories and metrics. Besides, the details button also allow you to display extra information without changing the structure of the table and use that to show the data more specifically. And the next one is actually filter. So filter is where you drag any measure and dimension to the filter shaft. And when you drop the field, the data field into the filter shaft, a box will appear in your interface where you may select any specific category or the top n rows based on measure values. Or actually you can create some rules to select top rows or by using some parameters. After you select the filter that you have just applied on the data field, you might need to click on the show filter so the changes that you have select will be automatically applied into the data set. Alright, so the next one is hierarchy. So hierarchy is used to keep your data ordered by layering similar types of relevant data together. So for example, Tableau's date time calendar is a hierarchy that you can explore down to year, quarter, month, and day by clicking on the add button on the features tab, as you can see from the picture. Alright, the next one is also by making changes on the parameter. So actually, parameter is a workbook variable in Tableau where you can see number, date, or string that the user can easily manage to substitute a constant value in a calculation. And then the next one is also calculated field. So Tableau gives us the ability to create a calculated field in which we can create our own new field or column, such as by using if-else, switch, case, date distinguish, and level of dimension. Alright, and the last one is actually the format. So Tableau has the ability to format the text, numbers, percentage, decimals, date time format, and other things that you might want to change the format of the data set. So you can use any of these steps to enhancing your analysis of your data set.
So for the first data mining task, which is classification, I'm going to present about the knife-based algorithm. So for this algorithm, the first thing we need to do is we have to modify the dependent variable. So the dependent variables are as shown in the figure. We have two dependent variables, which is the survive variable and the dead variable. As the variable needs to be in a numerical value, the calculated field is created for both survive and died variable. So the calculation is shown in the figure, which is for the survive. If the survive is equal to survive variable, I mean the data is survive, then the value will be returned to 1. If the data is if the value of the data is not survive, the return value will be 0. Meanwhile, for the dead variable, if the survive column is have died value, then it will return 1. If not, it will return 0. After that, we have to create the prior class probability as shown in the figure. The field is called p-survive, which is we have to calculate the probability of the survive passenger. So the created field will calculate the percentage of all passenger that is survive. To calculate that, the total number of passenger who survive will be divided by all passenger as shown in the figure. The formula is sum survive is divided by sum passenger. Next, we have to create a set of input variable. The input variable is for both survive and died outcome. For each input, the variable will be used to generate conditional probabilities. For this calculation, a fixed LOD calculation will be applied based on the categorical factor, which are the distinct of class, such as first class, second class, and the third class. The result that we will gain is the conditional probability of passengers surviving based on their class. As shown in the figure, the calculation is like that. Then, for a more accurate result, the class and the gender variable are needed, which means we need to calculate for both variable, gender and the class variable. Both of the input variable will be using fixed LOD calculation also, as shown in the figure. Next, after that, we multiply all of the probability to generate an overall probability field known as P. So, based on the Bayes theorem, we need to calculate the numerator value, which is probability of B. The probability of B is the prior probability of the predictors or all condition combination. As shown in the figure, the calculated field is P survive. So we have to multiply the class, the passenger that is survive based on the variable of class, gender, and the survive probability field. Then the numerator, which is P survive, is divided by our probability of condition regardless of outcome or field, which is P. Lastly, the final probability field is used to normalize the two outcomes as shown in the calculated field, where the survival final is survival probability divided by the survival probability plus the death probability. So this is the final chance of surviving passenger, where the calculated field is called as prediction, where it can be used to forecast an outcome. For example, we can forecast that the passenger will survive if the probability of survival is greater than the probability of death. Here is the model prediction result for overall accuracy score. As you can see, the accuracy is 75% match, while the not match is 25%. The next one for the classification, the next algorithm that I'm going to explain is on decision tree algorithm. For the decision tree algorithm, first thing first, we have to create the data set as usual. We'll be using the superstore data set, which will be combined with the polygenic data set. The length of the tree that we want to create is 4 as shown in the figure. First thing first, we can sketch the decision tree that we want to create. As shown in the figure, we have 3 levels. The first one is the order priority. The second one is the ship mode, and the last one is the product container. So next, we need to figure out how to locate the dimension at each level of the visualization, which is the XY coordinate. The x-axis is the level of the tree that we want to create, and then the y-axis is the ranking of level details to display the proper flow. So the curve of each part in polygenic model is sketched in figure above. For this part, we have to create 4 indicators, which is index 0, index 1, index 2, index 3, along with the level. So firstly, we will be starting with the level 0. To create the index, we have to click on the default table calculation. As shown in the figure, the partitioning and the addressing, we have to insert the label according to its level to calculate the index that we want. After we have insert the partitioning label, we click the automatic option and then click OK. It will display the indicator set of the following index. We have to repeat 4 times, which is for the level for index 0, for index 1, index 2, and index 3, to calculate all respectively level, and the final result of the level value is generated after the index calculation is complete. as shown in the figure, we can see the index, the value of index 0, index 1, index 2, and index 3. After that, here is the final result of the visualization. And that's all from me. The next data mining task will be continued to my other group member.
So I'll be continuing my presentation with another part of the report, which is data mining task, and mine is forecasting. Okay, now let's begin. Okay, firstly you need to create a forecast. How to create the forecast? So once you open the Tableau applications, you need to drag the data from the data pane to column and row. You need to make sure that it consists of at least one dimension and one measure. And you need to choose either graph or charts according to the suitability of the data under the show me tab. Second, you need to drag the forecast from the analytics tab to view to create the forecast. And lastly, you can view the created forecast by dragging the forecast from the analytics tab. Next will be the labels in the forecast. To use the labeling function in the Tableau, you need to click the label box in the Marks tab. User can show the label of the forecast and can show the way the label will be displayed. You need to click on the show labels, and all the data in the forecast will be displayed in the line graph. So user can choose from the choices available at Marks to label to use the specific type of label. And note that to choose from Marks to label, make sure that the show mark label is checked. On the slide, you can see is the example if min and max label is chosen. So how to use the prediction intervals? Firstly, you need to right click on the UI, and after that the user can see a few options that can be chosen from it. You need to drag the cursor to the forecast and then select the forecast options. After selecting the forecast option, you can see a forecast dialog box will appear. On the bottom part of the forecast dialog, there will be a section where a checkbox of show prediction intervals. Beside it, there is a ribbon tab of confidence level percentiles, choices as shown in the right figures. There is where the confidence level percentiles can be manipulated. So the last part of the forecasting is enhancing forecast. So to enhance the forecast, you can drag another instance of the forecast measure from the data pane to the detail shelf on the Marks card. So the last part of the forecasting is enhancing forecast. So to enhance the forecast, you can drag another instance of the forecast measure from the data pane to the detail shelf on the Marks card.
Okay, my name is Alia Zarina. So I will continue the next data mining task, which is clustering by using k-means algorithm. Alright, before you start to cluster your dataset, you might need to download your dataset into your system first. So you need to import your data file into the Tableau workspace from your own devices. So you need to click on the data interpreter, which I have highlighted on the first picture, and then you might need to click on the present under the sheet step that I have also highlighted on the second picture in order for the Tableau to rectify and realign the dataset that has been uploaded into the Tableau. Alright, after you have inserted your dataset into the system, you might need to format your dataset. For your information, the column from your data source will be shown as the fields and will be displayed on the left side of the data pane. that you can see from the picture that I have inserted in the slide. And you may proceed with formatting the data set, which is by selecting the fields such as business tax rate, days to start business, ease of business, hours to do tax, and also lending interest fields. And after you selecting all these fields, you need to right click to choose the folders and creating a folder by rename it as a business. And then you can see all the selected above fields will be included in this particular folder. Next, you might need to create other 3 folders, which are development, health, and population. You may see all these folders on the left side of the data pane in the picture in the slide. Then we need to double click on the country, which I have labeled on the 5th step, and then you may refer to the mark pin that I have highlighted on the 6th step, where on that mark the Tableau will create a map view with a filled circle representing each country. Okay, so actually in order to getting the map view, you may click on the mark type on the mark pin and change to the map view, so you will get the dataset in a map view. We need to identify and adding variables for clustering. In Tableau, the variables are akin to the fields, so based on our dataset, we can work on those fields such as population urban, population greater than 65, which signifies the senior citizens, and then life expectancy female and life expectancy male, where it shows a country with a higher life expectancy, which signifies that people in that country tend to live longer and be more interested in traveling. And the last field that we can work on is the tourism per capita. Actually, this field doesn't exist in the dataset, and we can create it by using calculated fields such as tourism outbound and population total fields. So we can use this both calculated field and apply it in the formula that has been stated in the picture, where I have highlighted on the 7th step. Okay. Next, before we moving ahead, we might need to change the default aggregation from sum to average. And actually, Tableau can make it possible to aggregate measures or any dimensions, though aggregating measures are more common. Okay. Whenever we add a measure to the view, an aggregation is applied to the measure by default actually. So the type of aggregation that needs to be used depends on the context of the view. And actually we can change the aggregation for all the selected fields, and then we drag the fields onto the detail on the marks card that I have highlighted on the 8th step. Okay, in this 9th step, it actually shows on how you want to change the aggregation format for all the selected fields, and then on how you need to drag the selected fields onto the detail on the marks card. Okay, we can proceed to cluster our dataset. So firstly, you need to click on the analytic pins and drag the cluster onto the view so that the dataset will be clustered by the Tableau automatically. Although a Tableau can automatically decide the number of clusters to be created, we ourselves can also control the number of clusters and what variables that we want to compute for the clustering, as shown in the step 11. Next, in step 12, you can drag a field into the box to include the field for the clustering algorithm, or you can drag it out to exclude it. We should go with 4 clusters and the default variables for a better analysis. Please note that some countries did not fall in any cluster and have been marked as not clustered. Okay, in step 13, you need to click on the data pin on the left side of your interface, and then you can see from step 14 where it shows that the cluster is created as a new field and can be seen on the color shelf. And you need to drag this field onto the data pin on the left side of the interface to be saved as a group. Next, in the step 15, you need to click on the cluster fields in the marks card and click on the describe cluster option in order for the Tableau to describe your clustering dataset. Okay, lastly is to describe our clustering. So there's actually two tabs in our document, which are summary and models. As for the summary, it will give a summary of the results and the average values of each variable for every cluster in the dataset. As you can see from this slide, we can infer that cluster 2 has the highest average life expectancy for both males and females, highest total tourism per capita, and highest average urban population. This means it has a wealthy urban population with a larger life expectancy and seems to be a good market for the senior tourism industry. Alright, then as for the models analysis, it will show the various statistical value for all the variables or fields average value and show their statistical significance. We can see both result when we choose to cluster and when we choose to describe our clustering dataset.
Last but not least, for the conclusions, Tableau is a powerful tool for visualizing and analyzing data, but it has advantages and limitations to consider when choosing data management software. One major advantage is it is user-friendly interface, which allows users of all skill levels to easily manipulate data. With drag and drop functionality and various visualization options, even non-coder can create engaging visuals. Tableau's ability to connect to multiple data sources and its advanced analytic features like forecasting and statistics make it comprehensive data analysis tools. Tableau focus on narrative and interactive dashboard is another benefit. User can create a dynamic display that aids data explanation and effective communication. Collaboration feature make it easy to share with colleagues and constituents. However, Tableau has a limitation. Licensing and deployment costs can be high, limiting access for a smaller organization. While it offers diverse visualization, it may not be as customizable as specialized software. In conclusion, Tableau is a valuable tool for data visualization and analysis, offering a user-friendly interface, advanced analytics, and focus on storytelling. Consider factors like cost and customization needs to determine if Tableau meets your organization requirement. Thank you.